Welcome to the future of understanding. This is NeuroMind Insights, where we unlock the power of your mind.
You know the feeling. You spend an entire afternoon sitting at the piano or trying to learn how to juggle, and by the end of the session, the movements finally click. You get better and better, and you go to sleep thinking you have it. Then you wake up the next morning, sit back down, and attempt the exact same skill. And somehow those improvements from yesterday are lost. Why does the brain seem to hit a hard reset on our skills overnight? For decades, much of what we understood about the brain turned out to be incomplete. We used to think the brain could not change after childhood, and that it remained silent when you were at rest. But advances in technology, like MRI, have shown us that every time you learn a new fact or skill, you change your brain. This constant physical alteration is a process called neuroplasticity. To understand why you lose a skill overnight, we have to look at the physical difference between how a fleeting thought and a permanent memory actually sculpt the brain. So what is physically happening inside your head when you experience a short-term memory? This animated diagram shows the first layer of learning, chemical change. To support short-term memory, your brain increases the concentrations of chemical signals transferred between neurons. This supports a rapid but temporary improvement in performance. But if those chemical signals are strictly temporary, how do we make a skill permanent? That requires the second layer of neuroplasticity, structural change. During learning, the brain actually alters its physical connections, growing new structures to build a permanent bridge between cells. Building this physical structure takes time and a specific type of practice. Research shows that increased difficulty and struggle during a session actually lead to greater structural change in the brain. This is why skills seem to reset. Your afternoon practice was enough to trigger a temporary chemical flood, but for some reason, those changes did not induce the structural connections necessary to support long-term memory. If individual connections between neurons change one by one, how does dedicated practice alter the overall map of your entire brain? This brings us to the third layer, functional change. As you use a brain region, it becomes more excitable and easy to use again. With enough repetition, the brain shifts how and when whole networks of activity are activated. We can see this in people who read Braille. Because they rely so heavily on touch, the hand sensory areas in their brains are larger than in those of us who don't. We see it again in London taxi drivers. Because they must memorize the city's map to get their license, they have larger brain regions devoted to spatial and mapping memories. But is this constant rewiring always beneficial? Neuroplasticity works both ways. It can be positive, like refining a motor skill, but it can also be negative. This exact same structural rewiring mechanism reinforces the loss of old skills, such as drug addiction and chronic pain. Your brain is being shaped both by everything you do and everything you don't do. If the human brain is this adaptable, why do some children thrive in traditional schools while others don't? Why do some of us learn languages easily while others excel at sports? To find the answer, researchers look at how the brain recovers from a stroke. It provides a specific window into how the brain attempts to reorganize and rebuild its damaged networks. The most informative data we've collected from these patients shows that patterns of neuroplasticity are highly variable from person to person. This biological reality means the popular 10,000-hour rule is a massive simplification. For some of us, mastering a skill will take much more practice. For others, it may take far less. Because no two brains are structurally identical, universal educational models struggle to reach every student. True progress in neuroscience will come from understanding these individual differences and matching learners with the right teachers and strategies. Instead of following generic recipes for success, we have to adopt personalized learning. You must study how and what you learn best, and repeat the behaviors that are healthy for your specific brain. We also have to reframe difficulty. That sense of struggle during practice isn't a sign of failure. It's the biological work required to move past temporary chemical changes and into permanent structural growth. You and your plastic brain are constantly being shaped by the world around you. By choosing your behaviors and your habits carefully, you can go out and build the brain you want. What is a specific new skill you are currently trying to wire your brain for? Let us know in the comments below.
Thank you for watching. If you enjoyed this video, please like, comment, share, and subscribe to NeuroMind Insights for more.